How can I use smaller rectangles to find the area of this rectangle? In this lesson, you will learn how to find the area of a rectangle or square by breaking it into smaller rectangles. So let's review. Area tells us the amount of space a polygon takes up. So all of this space inside of the polygon is the area. Let's also review that when talking about or finding the area, we're talking about the length and the width. And to find the area, remember, we multiply the length times the width. A mistake you might make is adding the side lengths to find the area. We add all of our side lengths to find the perimeter, but remember, we multiply one length and one width to find the area. So I have two paintings that I'm hanging up right next to each other without any space in between. I have a blue rectangle and an orange rectangle. And I want to find of how much space they will take up on the wall. So my blue rectangle is 8 inches wide and 3 inches long. My orange rectangle is also 8 inches wide, but is 5 inches long. So the first thing I'm going to do to find the areas is I'm going to find the area of the blue rectangle, and I'm going to add it to the area of the orange rectangle. Because remember, I'm finding the total area that these two shapes find up. And when I find the total of something, I need to add. So my blue rectangle is 8 inches and 3 inches. So that number sentence would be 8 times 3. My orange rectangle is also 8 inches and is 8 inches wide and is 5 inches long. So now I'm going to add 8 times 5, because remember, I'm adding the area 8 times 5 of the orange rectangle. So to find this out, I'm going to multiply 8 times 3 to get 24, plus 8 times 5, which is 40. 24 plus 40 is 64 square inches. Now remember, multiplication comes first. So I multiplied my two multiplication sentences, and I added those products together. Now let's go back to that first question. How do I break this rectangle into smaller rectangles to help me find the area? Here's how I will break my rectangle down, or how I will decompose the area into two smaller areas. I can use what I know about breaking down numbers again to find the area of this shape. So here are my new rectangles, a black rectangle and an orange rectangle. The width of both rectangles is 5 units. They happen to share the width because there's no wider part to the shape. The length of the black rectangle is 4 units, and the length of the orange rectangle is 2 units. Oh, sorry. Before we talk about the length of the orange rectangle, first I'll write down what my number sentence will be. So my number sentence will be 5 times 4 for the black rectangle. And then, like I said, my orange rectangle is 5 units wide and 2 units long. So I'm going to add that area. So that's 5 times 2. So now my number sentence is 5 times 4 for the black rectangle plus 5 times 2 for the orange rectangle. 5 times 4 is 20 plus 5 times 2, which is 10. 20 plus 10 equals 30. So the total area of this shape is 30 square units. In this lesson, you have learned how to find the area of a rectangle or square by breaking it into smaller rectangles.
How can benchmark numbers help you decompose this array? In this lesson, you will learn how to decompose a rectangle by using benchmark numbers. Let's review. What are benchmark numbers? 5, 10, 25, 50, 100? Benchmark numbers help us make estimates. The area of this array is 3 rows by 9 units. 3 rows times 9 units equals 27 square units. Let's decompose or divide this array into smaller parts. We will use benchmark numbers, 5, 10, 25, 50, 100. Let's use benchmark number 5 because it's closest to 9 square units without going over. 1, 2, 3, 4, 5. We'll draw an imaginary line, decompose or divide our array. We now have 2 arrays. We started with 3 rows times 9 units, which equaled 27 square units. We now had 3 rows times 5 units, which equal 15 square units, and 3 rows times 4 units, which equal 12 square units. 15 plus 12 equals 27 square units. The areas are the same. The area of this array is 4 rows by 8 units. 4 rows times 8 units equals 32 square units. Let's decompose or divide our array using benchmark numbers. We'll use the number 5 because it's closest to 8 unit squares without going over. 1, 2, 3, 4, 5. Draw our imaginary line, decompose or divide our array. We started with 4 rows times 8 units, which equaled 32 square units. We now have 4 rows times 5 units, which equal 20 square units, and 4 rows times 3 units, which equal 12 square units. 20 plus 12 equals 32, and the areas are the same. The area of this rectangle is 12 rows by 4 units. 12 rows times 4 units equals 48 square units. Let's decompose using benchmark numbers. We will use 10 because it's closest to 12 rows without going over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's draw our imaginary line and decompose or divide our rectangle. We started with 12 rows times 4 units, which equaled 48 square units. We now have 10 rows times 4 units, which equal 40 square units, and 2 rows times 4 units, which equal 8 square units. 40 plus 8 equals 48 square units. The areas are the same. Let's find the area of this rectangle by decomposing. 4 rows by 7 units square. 4 rows times 7 units equals 28 square units. We will decompose using benchmark numbers, and we will use the number 5. 1, 2, 3, 4, 5. Draw our imaginary line and decompose this rectangle. We now have 4 rows times 5 units, which equal 20 square units, and 4 rows times 2 units, which equal 8 square units. 20 plus 8 equals 28 square units. We started with 4 rows times 7 units, which equal 28 square units, and our areas are the same. In this lesson, you have learned how to decompose a rectangle by using benchmark numbers.